Hey guys, in this session we'll be looking at three merit questions from 2012. So looking at the first question in algebra, we have 1 root of x squared plus qx plus p is twice the other. Find the value of p in terms of q. So what we have is, if they say 1 root is twice the other, so when we solve this equation, let's say your first root is alpha, so that's your first root, then your second root is going to be 2 times alpha. So with that in mind, what we could do is we could write it up as basically this quadratic. We could write it as x minus alpha multiplied by x minus 2 alpha, and this is equal to x squared plus qx plus p. So when we expand the left hand side, we're going to get x squared minus 3 alpha plus 2 alpha squared, and this is equal to x squared plus qx plus p. So from here we can see that the coefficient of q should equal minus 3 alpha, oh sorry, I forgot an x there, should be an x there, 3 alpha x, and then the coefficient of the p, which is the constant, should equal to 2 alpha squared. So what I can then say is q is equal to minus 3 alpha, and on the other hand I've got p equals 2 alpha squared. Now the question is actually asking you to write p in terms of q, so obviously I'm looking at this equation here and I want to get rid of alpha. So I'm going to go back to my q equals minus 3 alpha and rearrange it. So I'm going to get q divided by negative 3 equals alpha. So once I get that alpha, what I can then do is go back to my p equals 2 times alpha squared, and because alpha is equal to q over negative 3, I could write this as q over negative 3 squared, which means p then would equal 2 q squared over 9, and that's your final answer for this. So we've done p in terms of q. So for merit for this part, you really have to get down to here, and correct expressions for p and q is achieved. So obviously if you get up to this line here, you are looking at an achieved. Cool, that's algebra. Let's go to differentiation merit. Okay, with this question, you look at it first time and you go, oh man, I'm actually working with a differential equation. Well, you kind of not, but I think you just got to use some algebra first to figure out what k is, and then you got to work out what what the rate is. So if you look at it, the first point you have to notice is this right here, where it says the light intensity at the surface of the lake is 8,000 lux. So now x is the distance x below the surface of the lake. So we can say that when x equals to 0, the light intensity equals 8,000. And then we can say that when light intensity 5 meters below the surface, so when x equals to minus 5, we can say that the intensity is equal to 2,000. Now the reason I put minus 5 is because we're going below the surface, and that's why I've decided to put minus 5. Okay, now most of you that have worked with differential equations, or even just you might have done this in integration, you know that this particular value here is also known as the initial value. So what you can do is you can actually write that equation up as I equals 8,000, because that's the initial value when x equals to 0, e to the power of negative kx. Now if you don't actually believe me how I got that 8,000, you could go back and put 8,000 and 0 in the equation. So I'll show you guys here. So the equation is I is equal to I naught e to the power of negative kx. Now we know that when x equals to 0, I is equal to 8,000. So I can say that 8,000 equals IO e to the power of negative k times 0. Now e to the power of negative k times 0 will become just e to the power of 0. And what ends up happening is e to the power of 0 equals 1. Therefore, we can say IO equals 8,000. Well, that's just you don't need to show that. I mean, if you understand, you can just put it straight in this equation like this. And then now it's time to figure out what K is. So we're going to use this part here. So then we have, when x equals 2 minus 5, we have light intensity equals 2,000. So we can write this as 2,000 equals 8,000 e to the power of negative k multiplied by 5. Well, negative 5 really. So this can be rearranged as 2,000 over 8,000, which is a quarter. So we've got 2,000 divided by 8,000 equals e to the power of 5k. So then the next part, what you can do is, because 2,000 divided by that is 0.25 equals e to the power of 5k. And when I rearrange this, I'm going to get ln of 0.25 equals 5k, and 5k equals, sorry, I'm just going to write this again. So then k is equal to ln of 0.25 divided by 5. So then k equals, we got negative 0.277. So once we have this, we now can go back and differentiate the actual equation, the intensity equation, because we have intensity equals 8,000 e to the power of, now we said negative k, so negative times negative k would become positive k. So I'm going to write this as 0.277x. All right. Now, when I differentiate this, I'm going to get I equals 8,000 e to the power of 0.277x multiplied by 0.277. So this is intensity function differentiated. So what I then have, simplifying this, I have, let me just work it out, times 8,000, that's 2218 e to the power of 0.277x. Now I'm trying to figure it out when x equals to 5, because I'm looking at when at what rate is the light intensity decreasing 5 meters below. So I've got x equals to 5, and I need to figure out what I dash is going to be. So what I end up getting is I dash is equal to 2218 e to the power of 0.277 multiplied by, well, actually there should be negative 5. Negative 5. Let me find out what I get. So when I simplify this, I get 555.23. So basically this is telling me that the light intensity is decreasing at a rate of 555.23 lux per minute. Now, from the assessment schedule that I'm looking at, you don't need to worry about the units, but you're looking at a merit for that. And in terms of achieved, it doesn't actually tell you what you need to do for achieved, but I'm assuming that if you can actually differentiate this or get to that stage, you're probably looking at an achieved there. Okay, let's go to the next question. So with this question, we have a differential equation. Now we've got dy dx, and we've got y equals 1, x equals that. What do we got? Find the value of y when x equals to pi over 6. So the first thing we're going to do is we're going to cross multiply this, and we're going to write this as 4y dy equals 3 cos 2x dx. Now I need to integrate both sides. So when I integrate 4y, I'm going to get 2y squared. Well, actually, wait, let's just do that properly. So we're going to get 4y squared over 2 equals, and when I integrate cos 2x, I'm going to get sine 2x. And of course, that's divided by the differentiation of whatever this is, which is, in this case, is 2. And of course, don't forget your plus c. So we can simplify this as 2y squared equals 3 over 2 sine 2 of x plus c. So the first job is trying to figure out what c is, and to figure that out, we are going to use this here, because this says when x equals pi over 12, y is equal to 1. So substituting this, I'm going to get 2 times 1 squared is equal to 3 over 2 sine 2 pi over 12, as x is equal to pi over 12, and plus c. So what I end up getting is 2 equals 1.5 sine pi over 6 plus c. Now, when I simplify this, I'm actually going to end up with c is equal to 1.25. So now I have my equation. My equation is 2y squared equals 3 over 2 sine 2x plus c. Well, I already figured out what c is, which is 1.25. So there we go. So now that I'm trying to figure out what y is, when this is what it's asking, what is y when x equals to pi over 6? So we have 2y squared equals 3 over 2 sine 2 times pi over 6 plus 1.25. So we can write this as 2y squared equals 3 over, well, let me just get rid of the 3 over 2. So I'm going to get 1.5 sine 2 pi over 6 is pi over 3 plus 1.25. Okay, simplifying this, guys, let me just tool in this calculator and figure out what it is. All right, let me just put it like this. Y squared then equals 1.5 sine pi over 3 plus 1.25 and the whole thing divided by 2. So when you find the value of this, and if you actually square root it, you will end up with y is equal to plus or minus square root of 2.549 over 2, or you might just get plus or minus 1.13. Okay, so that's what you need for a merit. In the answer sheet, you'll actually say is you don't need the plus or minus sign, but I'll always say play it on the safe side. And for achieved, if you can differentiate it here up to here, you're looking at it as an achieved. Cool, that's it for this session, guys, and thank you for watching. I know it's coming late, this one, but yeah, I just had to get it out. So yeah, catch you tomorrow.